Now first understand this question. Two numbers A and B are chosen from the set 1, 2, 3, 4, so on up to 3n, and in such a way that what is the possibility of selection? What is the requirement for the selection? In how many ways can these integers be selected such that a square minus b square is divisible by 3? So first let us identify what is the condition for a square minus b square to be divisible by 3. Yes, for the number a square minus b square to be divisible by 3, then a minus b is divisible by 3, then the number is divisible by 3. Or what is the other possibility? Yes, the number a square minus b square is divisible by 3 provided a plus b is divisible by 3, right? Or there is also one more possibility. Yes, both are divisible by 3. Now we need to select two numbers a and b from the set 1, 2, 3, 4, so on up to 3n such that either their sum is divisible by 3 or their difference is divisible by 3, or both sum and the difference is divisible by 3. Now to facilitate this, let's follow this procedure. Now let us divide these elements 1, 2, 3, 4, so on up to 3n into groups based on the remainder obtained. This is very important. The remainder obtained by dividing with 3. Then there are a few numbers of this group which are directly divisible by 3. So those numbers would give us remainder 0. Let's put them under the group Z0. Similarly, there will be some numbers which will give us, so let us see what are the elements in Z0. Those numbers which give a remainder 0 when divided by 3. That means they would be in the form 3, 6, 9, 12, 15, so on up to 3n, right? And how many such numbers will be there? Yes, there will be n such possibilities in this. There are n numbers out of these 3n numbers which belong to the group G0, which is the group of all the numbers which leave a remainder 0 when divided by 3. There will be another group which is called G1, such that every number in this group will leave a remainder 1 when divided by 3. How will be these numbers? Yes, we are talking about 1, 4, 7, 13, 10, 13, so on up to what would be the last such collection? 3n minus 2 will be there in this group. What are these group elements? They will have 1 as a remainder when divided by 3. And how many such numbers will be there? There will be again n such numbers in this group G1. Yes, there will be another group which leaves a remainder 2 when divided by 3. There will be 2, 5, 8, so on up to what would be the last number in this? 3n minus 1. And how many such numbers will be there in the group G2? Yes, that also will have n numbers in it. Now what do we need? We need such a selection of two numbers whose difference is divisible by 3 or whose sum is divisible by 3 or both sum and difference are divisible by 3. So shall we say the required selections is one possibility of both A and B selected from G0. Then what will happen? Yes, it will satisfy this condition. Both sum is divisible by 3 as well as the difference is also divisible by 3. If you take any two numbers of the G0 group, then because they are already divisible by 3, their sum is also divisible by 3 and the difference is also divisible by 3. Or there is one more possibility. What is that possibility? Yes, both A and B are taken from the same group G1. What will happen if we select two numbers from the group G1? Yes, the sum will not be divisible by 3, but the difference of the numbers would be divisible by 3. Right? If you take any two numbers out of this group, that difference would be definitely a multiple of 3. Or there is one more possibility. Yes, both A and B, both the numbers are selected from G2. Then also the two numbers difference would be again divisible by 3. And because the difference is divisible by 3, the product a square minus b square will be divisible by 3. Yes, there is one more possibility, or one is from G1 and other number out of A and B is from G2. Then also the sum is divisible by 3 now, but not the difference. If you look at, take any one number from G1 and one number from G2, their sum would be divisible by 3, but not the difference. But anyway, if the sum is divisible, a square minus b square will be divisible, right? So now we know the different possible cases. How many ways can we select two numbers A and B from the one group G0 which has n elements in it? Yes, this can be done in NC2 ways, or by fundamental principle is plus two numbers to be selected from G1 group which is also having n elements. That means it would be NC2 ways plus both the numbers A and B be selected from G2 which is also having n elements in it. So this can be done in NC2 ways. Or now how many ways can we select? One from G1 and one from G2. Both G1 and G2 are having n elements in it. So this can be selected in NC1 into NC1 ways. Now when we simplify this, this is 3 times NC2, that is n into n minus 1 by 2 plus NC1 into NC1, that is n square. So which option is it satisfying here? If you observe, the option B, which has 3 by 2 times n into n minus 1 plus n square, is the number of ways of selecting two numbers A and B such that A square minus B square is divisible by 3, right?